everyone. Today I will discuss about the PSPM question for chapter 1. For the first question, ion is an element with a proton number of 26. It was found that the ion atoms have 3 different nuclear numbers 56, 57 and 58 respectively. Write the isotopic notation of these 3 isotopes of ion. As the question need the isotopic notation for the ion, the answer will be like this. As we know, in the isotopic notation, the above part will be the nuclear number which have been given in the question, and the below part, which is the 26, is the proton number for the ion, which also have been given in the question. Then the element symbol is Fe, which is for the ion. For the next question, a sample of ion contains 68.6% atoms with a nuclear number 56, 10.1% atoms with a nuclear number 57, and 11.3% atoms with a nuclear number 58. Calculate the relative atomic mass of ion. Before we determine the relative atomic mass, we need to find out the average atomic mass first. So, for average atomic mass, the formula will be like this. Which is the Q is for relative abundance, and the M will be the isotopic mass of the element. And for the next step, we will substitute the value into the formula. Then we will getting the answer, which is 56.327. And we need to remember, we need to write out in 3 decimal places, and then don't forget to write out the unit also. And then we can find out the relative atomic mass. So we will use the average atomic mass divided by 1/2 times the mass of 1 atom of carbon 12. Then we are getting the relative atomic mass for the ion. For the next question, we need to sketch and label the expected mass spectrum of ion. After we sketch the line, we need to label it. Where the y-axis will be relative abundance, and the x-axis will be the mass over charge ratio. And then we will draw out the line. We will label it with 68.6, which have been given in the question. And also we need to label with 10.1 and so on. So this will be our answer. For the next question, monosodium glutamate, a food flavor enhancer, has the following composition by mass of 35.51% carbon, 4.77% of hydrogen, 37.5% oxygen, 8.29% nitrogen, and 13.60% sodium. Calculate its molecular formula if the molar mass is 169.0 g/mol. Before we going to determine the molecular formula, we need to find out the empirical formula first. So, as usual, we need to find out the molecular formula, we need to determine the empirical formula first. So we're gonna write down the table. Before we write down the table, we need to find out the mass first. It is because the mass have been given in percentage. So for mass of carbon, we will use 35.51 divided by 100 and then times with 100 gram, then we are getting the 35.51 gram for mass of carbon. And also the mass of hydrogen, the 4.77 will be divided by 100 and then times with 100 gram. Then we are getting the mass of hydrogen. And then so on. After we determine the mass for the elements, we will use the table to find out the empirical formula. So for first, we already find out the mass. So now we need to determine the number of mole. For the number of mole for carbon, we need to use the mass divided by the molar mass for carbon, which is 12. Then we are getting the answer. And for hydrogen also, we will use the mass of hydrogen divided by its molar mass, which is 1, and then we're getting 4.77, and then so on. So for the ratio, we will divide by the smallest value 1, which is 0.5913. Then we are getting the ratio. So in the end, we will find out the empirical formula. After we find out the empirical formula, we need to find out the molecular formula. So we will substitute the empirical formula into the equation, and then we find out the molar mass for the empirical formula. Then we will getting the molecular formula. So for the next question, a solution with density 1.6 gram centimeter contains 8.0 gram of ammonium nitrate and H4NO3 in 500 ml of solution. Determine the molarity of solution. So for the equation for the molarity is mole of solute divided by volume of solution. As we know, the volume of solution, the value have been given in the question. So now we need to find out the mole of the solute. So for the mole of solute, we will use the mass of ammonium nitrate divided by its molar mass, which is 0.1, and then we will substitute into the calculation. And then we don't forget, we need to change the volume of solution into liter, and then we are getting the answer of 0.2. And also don't forget to write down the unit. For the following question, the mass of water used to prepare this solution. So we need to determine the mass of water. As before this, we already know the density have been given is 1.6 gram centimeter cube. So we will use the density to find out the mass of solution. And as usual, the volume of solution have been given, which is 800, so we will substitute, and then we getting the mass of solution is 800 gram. So for the mass of solution, the formula will be mass of solute plus mass of solvent. As we know, the mass of solute also have been given, which is 8 gram. So we will substitute into it, and then we are getting the mass of water is 7.792 gram. So we are getting the mass of water is 792 gram. So, but last but not least, for the last question, ethylene C2H4 is an important industrial organic chemical and can be prepared by heating hexane 6H14 at 800 degrees Celsius. If the percentage yield of ethylene C2H4 is 42.5 gram, C2H4 is 42.5%, calculate the mass of hexane must be reacted to produce 481 gram of ethylene. So, as we know, the percentage yield have been given, which is 42.5%. And then we will write out the formula for this percentage yield, which is actual yield divided by theoretical yield and then times with 100%. So we know the actual yield, the value have been given, which is 881 gram. After we substitute into it, so we are getting the theoretical yield 100. So we are getting the value for theoretical yield 1131.76 gram. After we getting the theoretical yield, we will find out the number of mole. So if you want to find out the number of mole, we will use the gram divided by its molar mass, and we will getting the 40.42 mole. After this, as we want to know the mass of hexane, we need to find out the mole of hexane first. So we will use the ratio. Then we will find out the mole for C6H14 is 40.42. So now we need to determine the mass. And we know the formula for determine the mass of hexane is mole times its molar mass. So we are getting the last answer. So we are getting the answer, which is 3467.12 gram. So that's all for me. Thank you.